Can you see my screen?
Yes, ma'am.
Yes, ma'am.
Okay, so we were discussing the Fibonacci series yesterday, right? So how does it work actually? Everyone has understood the logic, hopefully. Only thing is we have to look at how it works in the background, right? So now let us start again. So the first call was say Fibonacci with the argument 4, right? So fib4 will give two recursive calls because the recursive call is fib n minus 1. So just to revise quickly, it is fib n minus 1 plus fib n minus 2, right? The previous two terms, the sum of those terms is equal to the current term, the nth term, right? That is the relationship between the numbers. Okay. So fib4 is fib3 plus fib2, right? Fib3 is fib2 plus fib1 and so on, right? So you will terminate this recursion when you reach the base cases, right? So you have reached base cases for our problem. In this case is fib1 and fib0. 0 and 1 are the base cases. N is equal to 0, n equal to 1 are the base cases. So our recursion stops there. Okay. What is the value of um, the Fibonacci term? First term, fib1, that is 1, right? The first term is 0, that is fib of 0 is 0. Fib of 1 is 1. So we have written that here, 1, 0, 1, 1, 0. Okay. When you're writing the expression, fib of 3 plus fib of 2, this expression is evaluated from left to right, right? If it is a normal expression, x plus y, it is fine if these are normal variables. But now the variables have been replaced by function calls. Okay. So now fib3, which is there, that will be first executed. That will be first called. So from fib4, fib3 will be called first. And fib3, again, since the base case is not reached in fib3, it's going to call fib2 and fib1 separately. Okay. So first what will be called? Fib2 will be called, right? Because the expression reads fib2 plus fib1. Okay. So fib2 will be called, and then similarly for fib2, fib1 and fib0. So fib0 or fib1 will be called first. So what happens here is you have reached down the tree. From here you have reached here, here and here, right? So once you reach this fib1, this 1 is the base case. So 1 is returned to the calling function. So which is the calling function for this? It is this, the top one, right? So 1 is returned to the calling function, right? Next, this function had called fib1 and fib1 has returned the value, but it is also calling fib0. So it goes to fib0, and fib0, since it is the base case, 0 value is returned back to this. Okay. So 0 plus 1, 1 plus 0 is the expression, right? For this plus, that is why I've written a plus here for understanding it. So 1 plus 0. So what is the value that is computed here? 1 plus 0 is equal to 1. So fib of 2 gets 1 with it. Now similarly, for fib3 had called fib2 and fib1. So fib2 is done. So fib2 will return 1 to it. Once this 1 is returned to fib3, it will expect the value from fib1, right? So fib1 has returned, has finished because this is also a base case, and this will return the value 1 back to it. Okay. So the expression is 1 plus 1 inside fib3. So 1 plus 1 is 1
Two.
plus 1 is 2, right? So fib3 is done. Fib3 has completed 2. So its evaluation is done. So 2 will be returned back to the calling function, that is fib4, from where it was called. Okay. Similarly, fib 4 is now left hand side. This is done. Fib 3 is done. So it is going at the right hand side. Right hand side, what happens is, again, there's a call to fib 2. So it's going down, right? It's going down. And since fib 2 is calling these two, first it will go to the left. Okay. Left side is done because 1 is computed. So 1 is computed. So what happens is, 1 is returned. Okay. Similarly, now left hand side of fib 2 is done. Right hand side is fib of 0. So it is going down. It will go down and it will expect fib 0 to return. So fib 0 is going to return 0. Okay. So 1 plus 0 is 1. So the sum is 1. Now this is also done. Fib 2 is complete. So this value is returned back to fib 4, the calling function. And now both the values are there with fib 4 for it to return a value to main. That is 2 plus 1. So 2 plus 1 is 3. So this value 3 is computed and it is returned to the calling function for fib 4, which is nothing but main. So the answer is fib of 4 is 3 because the Fibonacci terms are 0, 1, 1, 2, 3. So this is fib of 0, fib of 1, fib of 2, fib of 3, and fib of 4. So this is the answer. Okay. So this is how it is working. Everyone has understood this?
Yes, ma'am.
Yes, ma'am.
Yeah. So you can try it. You can also do it for Fibonacci for some other term, maybe the fifth term, sixth term. It will be a longer tree, right? Okay. You can try it later on and practice how it works so that you understand the working. Yourself, you should actually do it so that you understand the working. Okay. Next, we will discuss more problems today. So next is the exponential function. So exponential function is given here, but you have to tell me now, how will you write it? So let us switch back. That is x raised to n. Right? What is the exponential function? X raised to n. Now you have to help me. How do we write this? We need to write a function x raised to n. So first of all, the arguments to the function will be x and n, obviously. Okay, we are writing the integer part of it, that is integer x raised to n. So everyone knows what is x raised to n. Mathematically, what is x raised to n?
X multiplied n times.
X into x into x dot 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 n times, right? Okay. Now I have to start thinking recursively for this problem. Okay. If it is iteratively, I know what I have to do. What do I have? What is the iterative solution for this? What is the loop based solution for this? I run a counter n times. Suppose I'm using the for loop. For I is equal to 1, I is less than equal to n, I plus plus. I run a counter, right? And what do? I say maybe the answer is in R, result, RES. Okay. So I say RES initially will be 1, right? RES will be equal to RES into X, right? This is the iterative solution. Everyone agrees?
Yes, ma'am.
Yes,
Now
ma'am.
for, yes, yes. So for now for this problem, you have to think recursively. So can I write this as x into x raised to n minus 1?
Yes.
Yes, ma'am.
Yes, ma'am.
So it tells you that if I want to, so if I start with the smallest version, it tells you that if I want to compute x square, it is x into x. Okay, if I want to x cube, then it is x into x square, right? And so on. That is how you get the logic. So ultimately, x raised to 4 will be x raised to 3 x multiplied by x raised to 3, right? So ultimately what will happen is x raised to n will be nothing but x into x raised to n minus 1. So if you know the solutions, smaller solutions, then you can compute the line. So this is how you think recursively. Now this is fine. What is the base case for this? Is the solution complete? No, you have to think of the base case. What is the base case?
X to the power 0.
What? X to the
X to the
power
power
0.
0.
So I know x to the power 0 is 1, right? So this could be the base case. This is when I need to stop. Okay. So now, given this logic, can we write the function? Let us write it directly on the. Let me write it directly here. Okay. Recursive power. Okay. Let me call it. This function is going to return a value. So let me say int recursive power int x and int n, right? Now in this function, I have to write the two cases, the base case and the recursive case. So how do I, what is that? The base case condition is, how will I write it? How do I write this mathematically? It is basically, I can write it mathematically like this. X raised to n equal to 1 for n is equal to 0. For n greater than 0, x raised to n is equal to x into x raised to n minus 1. Correct? So this I have to simply put there, right? So I will say if, what will I say? If x is equal to 0, I know the answer. So I'll return that answer. What is the answer? Return 1. Else,
N is equal to 0, no?
Ma'am, n
Ma'am, n equal to 0.
sorry, n is equal to 0, return, very good. Return 1, otherwise return, I have written here correctly, right? Yeah. Return x into, now I have to say x raised to n minus 1, right? So that is nothing but my power function. So that is this x raised to n minus 1. Fine. And inside main, what will you do? You will call this function. So you say simple, we will just pass some simple arguments and call the function. 2 raised to 5. Okay. Now let
Ma'am,
us, yes.
mat.h will not come.
Mat.h will come if you use any function from mat.h. Are you using any function from mat.h?
Oh, no, yeah.
That power function, it is in mat, but we are writing our own function, right?
Okay.
Hmm?
Ma'am, you have to also initialize the integer variable, no, ma'am? And you assign it to the return of value function.
Very good. So I need to say there are two ways to do it. Either I write the answer like this, right, in printf, or I have some variable assigned to this because it is returning a value, right? The function is returning a value. So there has to be a left hand side. Left hand side equal to the function call, right? This is one way, or the other way is I have an integer and I say k is equal to whatever we had written, this one. And then I say printf k. Right? This is one way. Are you getting it? First way is this. And this is the second way of calling the function for the function call. Since the function is returning a value. Fine. So let us call some other value here, 3 raised to. Okay. Now I will compile it and run it. GCC. What was it? So there's no new line which we have printed. That is why it is showing together. But the answer is correct, right? 81 and 32. Correct? 3 raised to 4 and 2 raised to 5. Fine. So this is the exponential function that you can write. What other problem we can write? GCD. GCD of two numbers. How to write it recursively? Okay. Can we think recursively for GCD? That we have to figure out. So what is the GCD? You have done the Euclidean algorithm, right? For GCD. Yes. Everyone is aware of GCD logic, right?
Yes, ma'am.
So the Euclidean algorithm you must have used. That is where you take the mod, right? You find the remainder. M is equal to N, N is equal to R is equal to M mod N, right? These three steps in a loop. And when do you stop the loop?
When the second argument is 0.
Okay. So can you think recursively for the GCD algorithm?
So the base case will be when b is equal to 0, return a, and GCD, and otherwise it will be return GCD a mod b comma a.
Okay. So
Or maybe the other way around.
okay. So for this, everyone knows the logic. So it is M. Suppose M and N are my two numbers. Okay. So what do I do? Say 12 and 4, right? So what do? I simply compute R. And I say, what is R? R is M mod N. That is 0 in this case. And then I keep on interchanging, right? So I say M is equal to N, N is equal to R. R is M mod N. Sorry. Okay. I keep on continuing this till my N becomes 0. The moment my N becomes 0, second number becomes 0, I stop. Okay. That is how I find GCD. And the answer, the GCD is in M, in this number, in this variable, right? This is the logic for GCD. Now you have to think recursively how you can put this. So these steps we were repeating so far in a loop. Now we have to think how we can do them recursively. So we stop when the n value becomes 0, so that we understand that our base case is n is 0. You need to stop the recursion when n is equal to 0. Okay, so, and what is a recursive call? The recursive call is simply you need to interchange, only performing interchange. So what, so initial call will be, initial call, suppose GCD is the name of my function. Initial call will be in GCD m comma n. These will be the two natural arguments to the function from main. Okay, that is GCD 12 comma 4 in this case. Next time, what do you need to do? You need to interchange. So you simply say GCD is, give a call to GCD n, and this n will become r. But what is r? It is m mod n. Right? So the call now will change. So initially it was, first call will be GCD mn. Inside GCD mn, you will check if n is equal to 0. What is the GCD? It is m. Otherwise, call GCD with, that is return GCD and m mod n. Correct? So if we run this, GCD return, if n is equal to 0, return m. Let me write it as m and n. Otherwise, return GCD n comma m mod n. Okay, and once you can call it here GCD of 3 and 4 and GCD of some other number 12 and 16. Okay, so recursive GCD. Right, GCD of these are co-prime numbers 3 and 4, right? So the GCD is 1 and GCD of 12 and 16 is 4. Everyone knows, right? You can try others also. So this is the recursive solution for GCD. So you have to start thinking. So the only way of learning recursion fast is, for every iterative problem, you start thinking whether you can express it as a recursive version. You have to start thinking recursively, because human beings do not think recursively. We think more iteratively. So we are more, the common way to think in terms of problem solving is iteration. It is not recursion. But to think recursively, you have to try to express every iterative problem in the form of recursion. Okay. So one more question we will do.
Ma'am, I had a doubt in this.
Yes.
Ma'am, how this will work? Means 12 comma 16, then it is m mod n, then 12 mod 16 won't come.
12. What is 12 mod 16?
It would be 0.
No. What is 12 mod 16? It is 12. Remainder. Okay, so it does not matter, the order does not matter in case of here, because mod operator will give you the, ultimately it will interchange. Fine.
Yes, ma'am.
So the correct answer is correct, na? 12 and 16, it is 4, na? It is giving. Otherwise, it would not have worked.
And ma'am, also in the Euclid's method, we have to interchange m and n if the m is less than n.
No, not required. You can interchange. If you interchange, one step will be less before passing it. Na? If you are interchanging, before passing it to the function, if you are interchanging, one step will be less, na? Because see, mod operator is a very beautiful operator. What happens is, in case of mod operator, if the number that you're dividing, so suppose something like this, 125 mod 5, if the number that you're dividing, it happens to be less than the numerator, then in that case it will do that division, and whatever is the remainder it will give you. If it is the other way around, it will still do the division, na? Division, remainder operate, everyone knows na, how to divide 5 by 125. What is the remainder? 125 will not go in it, so it will give you 5, right? So this is the remainder after division. Okay, so it gives you back that number. If the number is smaller, if the numerator is smaller than the denominator or the divisor, you can say, if the dividend is smaller than the divisor, then it will give back the dividend to you. That is why it works. Clear?
So show that stepwise 12, 16 का example.
Yes, definitely I can show it. So you want which one, recursive one or this one? What one? Which one you want?
Recursive GCD.
Yes. So first call is GCD 1216, right?
Yes.
Now what you will do?
M will
As the
be
base,
2
n is not, so this is, I'll just write for simplicity, m is n, this is m and this is n. Okay, now it happens so that base condition is not reached, so this is going to give a call to GCD n and m mod n. What is m mod n?
12.
What happened? What
Okay,
happened?
interchanged on its own.
Ah, exactly. So automatically it will get interchanged. Now it will keep on going, na? So
Yes, now
GCD,
understood.
now you're getting it?
Yes, ma'am, thank you.
Yeah. The beauty of the mod operator. You don't need to interchange. Anyways, next problem. One more problem. Okay, now you have to have this pattern. I'll add a page here. You want to write a program to generate this number pattern. But without using a loop, that is using recursion, you have to write a program so that you generate this kind of a pattern. Okay, so n is given to you, and n is a number from which the pattern starts. So n is given to you as 16. Okay, so if n is, do you notice some relationship between the numbers? Can you observe? Can you make some observations
Difference
and
is
tell me
5.
one by one?
Difference is 5. It keeps on decreasing, then keeps on increasing.
5.
Correct. And by what measure? By
5.
5. Right. So the very good. Your observations are correct. You see that the pattern keeps on decreasing. The numbers keep on decreasing till a point, and after that point they start increasing. Okay. One more example I want to give you. So if n is 15, then in that case the pattern is like this. Okay. So do you understand at what point it starts changing or increasing back?
If it is smaller than or equal to 0.
So when it is less than or equal to 0, when n is less than or equal to 0, it starts increasing again, right? So this is these observations are what you have to consider for writing the recursive solution for this particular problem. Okay, so what do you need to do? Of course, this is a print pattern, right? You're printing it. This is not going to return any value. The function will not return a value. It's going to keep on printing numbers recursively. Okay, so return type of function will be void and all that. And you inside the function, you're going to keep on printing the numbers. Now what will happen is inside the function, let me say print pattern. Okay, print pat is going to print the pattern. So one argument is the argument that it's going to take is the number n, right? The variable that it will take, the argument that this function will take will be the number n, because n you have to pass to the pattern, right? N can be 15, 16, 17, any value, any integer value. Okay, so inside this print, so this from main, this will be the call, fine. But now inside this print pattern, this function, what are you going to write? That is important. Okay, so I can write a printf. Let me start with printing the n value first. Okay, because the first value is n, so my job is done. Okay, n is printed, fine. At least I've printed n. Okay, after I print n, what do I need to do?
Just call print pat with n minus 5 as argument.
Okay, so let me call print pat with n minus 5 as argument. Okay, if I keep on doing this n minus 5, what will happen?
Go on infinitely.
Correct, because
Yes.
it is not going to end. So maybe I stop at, I need to stop, right? So I need to put the base case. So base case, so suppose I say that if n is equal to, if n is less than or equal to 0, I stop. Okay, I stop, I return. Okay, what will this do? This logic that I've written, what will this print? Let us see. For the first example, it will print n first. See what is happening, it's going to print n first. Okay, and suppose I'm using a space, %d and then space, right? So it
Then
will
it
print.
will move to the print pad with n
Then there's
plus
a call
5.
to, yes,
Yes.
yes. So what happens is print, let me say it is print pat 16 is going to print n first, that is 16. Then it's going to call print pat with, let me make it pp, that's better, pp with 11. Okay, then it's going to print 11. Okay, then pp11 will give a call to pp
6.
6.
6, will it will print 6. Give a call to pp1, it's going to print 1. Okay, this gives a call to pp minus 4, and at that point what happens is pp minus 4 is reaching the base case, right? So it is not printing it. So what do I need to do? I need to write a printf. So I'm printing printf again n, and then I return. Okay, fine. So what happens now? pp4 minus 4 has printed, so this much is printed, right? This much of my pattern is printed. Sorry, this much of my pattern is printed, right? And what has happened? pp minus 4 is done recursion. This function has finished printing. It will return to the calling function, right? Now in pp1, PP1, what was the line which was last executed? It was this one, this line. Yes or no?
Yes, ma'am.
Ha. So what is the line after this? Nothing, na? So it's going to return statement will be added implicitly. It's going to return, na? It's finished because it got the value, it will stop. Similarly, it will return to whom? It will return to the calling function, that is PP6. Okay. Now PP6 also finish the last line, it will return to the calling function and calling function. So what we have done by writing this code is, we have got the left hand side of the pattern correctly. So any pattern that you have starting from n value, any n value that you have, left hand side this is going to print, right? Everyone agrees?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
You are understanding now how it is working, it's how it is returning, because it's reaching the base case. Base case is making all the returns implicitly because it's returning to the calling function, and calling function is finished executing. That was the last line, so it will stop executing. Stop executing means it will return to the calling function, and it will keep on going to the parent till it reaches the root, right? Till it reaches the first call. Fine. Now what is important is we have to think of the right hand side of this pattern.
We add a printf n line after the return.
After the return, which line?
Um, when we say
Before the
return,
return.
yeah, print pat n minus 5. After that, we'll add another printf n. So whenever it comes back, it will complete the printf n
Very
again.
good, very good, very good, very good. So that was a hint, whatever I was telling right now. Okay. Fine. Now that I return from -4 back to PP1. Everyone is at -4 now. Okay, -4 is printed. Now my job is to print which is the next number that I need to print. I need to print 1 back. Yes or no? I need to print 1 back. Okay. Now that I return from PP -4 to PP1, in this case, I am at this line, right? I am at this line. Okay. And the value of n in this function is currently what? In this function, in PP1, it is what? It is 1, right? The value of
1.
n is 1. I have not updated it. It's 1. So I can still print it back after this line. I can write a printf statement.
Yes.
You are answering. Let others respond. So when I return from PP -4 to PP1, then this was the last statement. But now what I did, I made an addition. I added this line again because I know that the value of n with me right now is the same value. So can I print it? Of course, I can simply print it. So after this particular line, I write a printf. Okay. Similarly, from 1, so now what will happen? Now this part, right part will start printing. So 1 will get printed. Now again, there's a call back here, call to this, a return to this function. So in PP6 again, that printf n is there, so it's going to print 6. Are you getting it? Then again, it will go return back to 11. In 11 again, that 11 printf n is there, so it is going to print 11. Okay, and finally in printf 16 also, that n is there after this line, right? So it's going to print 16, and then it's going to return to main, that is a calling function. Is it clear?
So the code is the below 3 lines after if ना वो बीच का नहीं है ना वो printf जो आपने लिखा है और return
है ना वो बेस केस है, that is your base case, because that is going to stop na the recursive calls, the tree, it's going to go down and down and down. When will it stop? When it reaches minus or negative value or 0 value. In case of the first pattern, it will stop when n is equal to -4. In case of the second pattern, it will stop when n is equal to 0. Then it will start moving up. Na? Otherwise, it will keep on going down. So that is required.
Okay, so that return after in the second line or after the if
Return is not required. Return is implicitly put. In case of a void function, if I don't know whether you have studied properly or no, in case
Yeah,
of a
I've
void
studied.
function, in case of a void function, you do not need to write the return statement. Na? Have you written
Mhm.
any? No, na? Because that
Mhm.
return is it's optional. Only printf you need to write, huh? For that base case.
मैम
Okay.
वो सेकंड वाला पार्ट समझा दो ना 1 to 6 to 11 कैसे नहीं समझा
You have understood the left part of it, everyone, right? How it works?
यस मैम
Okay. Let me see. What happened? Okay. Let us write the pattern. 16, 16, 11. What was it? Minus 5 now. 6, 1, minus 4, 1, 6, 11, 16. Okay. So what we were doing is print pattern 16 was our first call. That is calling print pattern 11, which in turn is calling print pattern 6, which in turn is calling print pattern 1, which in turn is calling print pattern minus 4, and this is our base case. So once our base case reaches, we need to return back. Okay. What is our function? Our function that we have written is if n is, let me use another color. Again, the same color. Okay. If n is less than equal to 0, then I need to stop the recursion. But before stopping the recursion, I need to print, na? Because otherwise this minus 4 will not be printed. Everything else will be printed 16, 11, 6, 1. Why? Because it is in the else part. But minus 4 will not be printed. So I say printf %d, leave some space, one space, and then I say n. Okay. And in the else part, I say printf %d print pattern n minus 5. Okay. So everyone has understood that I need to write that printf statement inside less than equal to 0. Yes or no?
Yes, ma'am.
Yes, ma'am.
Because otherwise it will not print it. That one number it's not going to print either 0 or minus 4, whatever is the case. Now that it has reached minus 4, base case is done, right? We have reached the base case. So for this function call, pp of minus 4, inside pp of minus 4, inside the body of pp with minus 4, it has reached this if condition has become true. So this function returns to the calling function, that is pp1. Okay. Now in this call, now we are in pp1. Now let's erase this. Now we are in pp1, right? Inside pp1, at which point you are in the code? You are at this point, right? Now since you are at this point, your function is done, na? Your function is done. Your pp1 is done. Yes or no? Whoever asked the doubt.
यस मैम
Yes, ma'am.
So now, but my job is not done, because what happens is if this function is done, again this is going to return, and my right hand side will not get printed. But I want to print the right hand side. So I will use a trick. The trick is, I know that currently at PP1, I'm in PP1. I know what is the value of n in PP1.
1.
It is
So
1.
write a printf
So now you're writing a printf statement. So I write a printf statement here only, below this. I write printf n. So now as a result of this, it's going to print 1. Okay. It's going to print 1. And then now it will return to the calling, because now it is done, and now it's going to return to the calling function. Calling function for PP1 is PP6. Okay. Again, PP6 you are at this point. Now this 1 becomes 6, right? So you are at this point. So this statement has executed. After this, again, it's going to print 6, right? And it will return to the calling function. Are you getting it now? Are you getting it now?
Yes, ma'am.
Okay. So now I just want to modify this particular question slightly. And I want to say that I have two numbers. One is n, the usual n from the number from which the pattern starts. And one is k, the interval k. The k value could be any value. It could be 5, it could be 3, it could be any interval. Okay. Suppose k is 3. What will this pattern look like?
16, 13, 10, and
16.
so on.
K is 3. For k is equal to 3, 16, 13, 10, right? Are you getting it?
Yes.
So I've modified this problem slightly now. 1 minus 3, na? ऐसे ही जाएगा ना? 1 minus 3 is minus 2. And then it will come back, right? So I've modified this problem slightly. Now, instead of having one argument, I will have two arguments. What will be the changes expected in the code?
PP n minus k.
PP n minus k. Very good. And k also has to be passed then in this case, right?
Yes.
Although k is not changing, you can pass k as well. So I will just show the code. I have it with me. I've written it. So this will be the code. Correct? Everyone can see the screen, right?
Yes, ma'am.
Yeah. So one example I want to tell you to try, that is finding the digits of the number, some of the digits of a number using recursion. Okay. You have to think of the logic and practice it. Sum of digits of a positive number using recursion. And the problem that we just discussed just a while ago, that problem you are supposed to do in your practical. One of the questions is that problem. Okay. This one is for homework. That means you have to do it sincerely. You all are not practicing sincerely. See, if you want to improve your programming, you have to keep on solving problems and you have to keep on writing those codes. Okay. Think of the logic, chalk down the logic, and then you write the program. Type the program, execute it, run it. Okay. That is how you learn. I can teach you 3-4 programs. That's it. Rest all you have to practice. Explore more. There are so many resources online. There are so many resources where you can practice. Just look down for problems for practice. Even I give you some. I'll give you a list of problems for recursion also. I'll upload it definitely on classroom, but you also have to explore. Okay. So that's all for today.
Thank you.
Thank you, ma'am.
Thank you, ma'am.
Yeah.
Thank you, ma'am.
Thank you,
Thank
ma'am.
you.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.